Hey everyone, welcome to part 2 of my guide to volumetrics in Maya using Arnold. It's been a minute since part 1. I got busy and then Christmas happened and then I got sick. Such is life. Now in part 1 we covered everything from using our environment settings to creating a vol box so that we could get that volume AOV result that we could work with. And we also went over how we could isolate our volume sources using the RGB channels on a separate render layer for further control. Now in this video, we're going to go over 2 alternate methods. The first one will be a bit of a combination between the vol box approach as well as the RGB channel separation method. However, we will not have to create a separate render layer for this method. And then for the second approach, we're going to go over a light group AOV workflow where we will only use the light group AOVs to isolate out our volumetrics. It will give us a lot of control while still keeping everything within a single multi-layer EXR file. So both of these methods will give us maximum flexibility and control within our look dev and compositing workflow. And so depending on what you're working on or your personal preference, you might want to use one or the other, but I'll leave that up to you. With that said, let's jump into the first method. For this method, you will need a volume box within your scene just so that you can actually see the volumetric result on your beauty pass, and then also be able to achieve a volume AOV result. And so you'll see it right here. You might recall in the first video in the second method, this is kind of what I set up in that portion of that video. So if I just select it here, you'll also see that I have drawing overrides turned on in the shape tab. If you go to the object display, you'll see under drawing overrides, I have that enabled, and then I have bounding box turned on as well. That's just so that I can actually see through the cube and actually kind of navigate my scene otherwise. And so again, Arnold requires a physical volume object to actually generate an alpha and output a volumetric AOV result. You can't rely on just the AI atmosphere volume shader plugged into your render settings inside of that environment tab in your Arnold renderer tab. That will not work. It will not produce a volume AOV. You will see it in the beauty result, but not in any kind of volume AOV that you might have selected from your list to make active within your scene. If you go to that drop down in your Arnold render view, you will not see a result. It'll just be black. So the setup here, again, it's similar to the second method that I used from the previous video, as well as the second render layer approach that I went over in the part 1 portion of this series. The similarities are in that, once again, we are using a volume AOV to generate a result that we can kind of separate out and then add back on and adjust. Now, the similarities to the second render layer technique that I went over in the previous video are that obviously I've separated my volume sources into the RGB channels where I've made them pure red, green, and blue values so that they can further be isolated and separated out in comp to make those isolated adjustments. And so what I did was I just, again, duplicated my original lights and then I put them in this vol lights group, named them accordingly with vol at the end of the names. And then these duplicates only contributed volumetrics to the scene. So you'll see the visibility attributes for the rest of those attributes for each of the lights in their settings are brought down to 0. And then the volume contribution is only brought up to whatever it may have been. And that's just based off of what I had set it in the previous video for each of these volume specific lights. And then for the original lights, they're only not contributing volumetrics, but they are contributing the rest of the default attributes, such as diffuse, specular, etc. And so that's why we see the result that we're getting. Those original lights are affecting the underlying geometry on the beauty pass, and then those volume specific lights are visible just within the volumetrics, of course, with their clear RGB result that they're giving us. And so this workflow is essentially a merger of the 2 approaches, again, that I went over in the previous video, that second method, as well as the second render layer technique. Now, of course, in this case, we just aren't using any render layers. We're just using the volume AOV instead. And so if I just go click off that so that I can see my active IPR that I had going, you'll see that my IPR is actually currently going and active because this has switched over to the stop button. And so if I go over to the AOV list, you'll see my active AOVs here, and there's that volume AOV separated out. So what we can do then in comp is basically take this, subtract it from the main beauty pass, and then isolate those RGB channels using shuffle nodes so that we can make isolated adjustments to them after the fact. I'll go over that a little bit later more specifically. I've also set up these other light groups here where we can see the isolated light group results from each of the light sources within the scene in terms of the original lights. And so I set those up by just going to the AOV tab in the render settings, and then I clicked the add custom button here, and then I just typed in RGBA underscore, and then I added this specific name for what I wanted the light group to be called. And then in each of the corresponding lights, you can just basically take that primary name that you want to use for the light group, and then just add it into your AOV light group input box there. And so you'll see that's what I did here just for the original lights. So I have that one as top, this one as side far, and this one as side near. And then this gets me those results there. You do not need the RGBA prefix in the actual input box for each of the lights within their settings. Just the primary light name will suffice. You do need that for the actual active AOV name in your AOV tab of your render settings in order for them to be recognized as light group AOVs. Now, of course, one thing to consider during your look dev process when you might be building up your lighting and what have you is that your beauty pass will show the red, green, and blue volumetrics as you see them here. And so that can be a little bit misleading compared to the final results, and it might throw you off a little bit. So in that case, you can just switch them over to the RGB colors once you have things closer to final in terms of your lighting setup. You can either duplicate these a little bit later in the game when you're closer to rendering out your final result, or you can duplicate them earlier and then just leave the color for each of these lights as their kind of original colors. I can just turn on the use color temperature there for those. And then I could just switch this one back to white from that pure red. And then when I'm ready, I can just switch them over to the RGB colors, and then you'd be kind of good to go. But that is otherwise one of the drawbacks of this approach. And so again, a good workflow is just to test with the lights as their natural colors, and then switch to the pure RGB colors before you do your final rendering. That way you're not thrown off while you're building your final look. And so once you're done and ready to go, you can just kind of switch those over, turn off your use color temperature, make sure you have the color otherwise set to that pure green and blue, and then red for whatever other group of lights you may want to be included in that red channel, and then you would be good to go. And so this is a kind of a nice approach because it consolidates everything into a single EXR file. There's no render layer setup required. There's one less file once again. And so in a sense, it kind of streamlines the workflow a little bit. The one downside once again is just the kind of look dev process, and your kind of iteration time may be a little bit affected by that depending on your workflow and how you decide to approach it. But that is the first alternative approach that I wanted to go over in this video. In the next approach, I'm going to go over how we can just use light groups strictly to separate our volumetric sources without using any kind of RGB channel separation. So let's look at that one next. All right, so for this approach, the second bonus kind of method, as it were, I'm just going to show you an alternate way that we can go about separating out our volumetrics so that we can have isolated control over them once again. This is not using the RGB separation technique in this case. We're kind of going back to that second method in the previous video where we're just using that volume box to get AOVs, where we will then be able to come out with isolated control over our volumetrics. We're using essentially light group AOVs here to isolate our volumetric sources onto their own respective AOV pass. So we're not going to use just the wholesale volume AOV, which would just provide a result from all of the lights that are contributing volumetrics into the scene in a combined pass. With this approach, we're kind of being a little more granular, where we're specifying what sources we want to be added to a specific custom light group AOV pass so that we can see that result on it. And you can do that however you'd like. You have full control over that. And so since we have separated out our volume lights, we're still doing the same thing that we did in the last bonus method that I showed you. And then the last couple render layer techniques in the last video, where we have our volume lights in a separate group and they're named kind of accordingly, indicating that they are only contributing volumetrics to the scene, as you can see, with their volume visibility set to 1 and the rest of their visibility attributes zeroed out. And then the original lights are still not contributing volumetrics, but then they're contributing every other thing to the scene effectively. And so as a result, if we create a light group and then assign just these volume only lights to them, again, if we had a scene with street lights, you could put all of the street lights on a single light group AOV, like the volumetric contribution version of those streetlights, and then you'll only see volumetrics on that AOV. So essentially, it's kind of like that same volume AOV pass that we created before. It's just a little bit more custom and specific in terms of how it's set up and what sources are included on that AOV pass specifically. And then you can create another custom light group AOV for say car headlights or flashlights from characters that might be walking around, and you can kind of create separate light group AOVs relative to those instead of using, say, render layers like we went over in the last video. So this is just another way to go about doing that. And so in this scene, since we just have 3 lights, I just put each of the lights in their own respective light group AOV to illustrate that. And so you'll see I've created these. I just went add custom, and then I typed in RGBA. As you need to do that, you need to add that prefix for it to be recognized as a light group AOV when using Arnold and Maya. So once you've added that, you can add whatever name you want here. It could be, you know, street lights, or in this case, it was just top or side near, or what have you. So you'll see how those have been separated out. So I made light groups, not just for the volumetric contribution to get volume AOVs for the volume sources, but also for the original lights as well. And that gives you even more flexibility and control in comp to be able to rebuild those light groups to create your final beauty pass result, to kind of recreate it. And then you can also then manipulate the color and intensity of not just the volumetrics, but also the original lights that are affecting the underlying geometry on the beauty pass here as well. So I'm going to show you how we can do that in comp in a little bit as well. Now you'll see I also have those volume specific light group AOVs as well, of course, and so that is corresponding more to being able to isolate those volume specific lights onto their own AOV so that you can then again adjust the intensity or color of the volumetric sources specifically. So once I've created those, again using the custom button, add custom, you would go then into each of the lights. So I did that here for the originals and just put in top. You don't need the RGBA prefix there. And then for side near, I just put side far, or side far, I put side far. For side near, I added side far in the AOV light group input box there, in the visibility dropdown for the light attributes for each of those. And then I did that for the volume lights as well. So I just added side far underscore vol, just the same relative naming based off of how I named the light group AOV in the render settings for it. So this would actually be side, or no, that's the top one. So that would just be top underscore vol. So that's what you would need there. And then for the other one, it would just be, you know, side far underscore vol. And then this one would be side near underscore vol. With that set up, when you do a render in the Arnold render view and you go to your AOV dropdown, you should then see what that would look like. You'll see all those AOVs in the drop-down list for the AOV options, or lists, or whatever you want to call it. So if you click on those, you'll see the result that you're getting. And it's just complete isolation then from those AOV specific lights onto their own AOVs, as we would expect. And then if we click on these, you'll also see just the original light contribution from the original sources, light sources in the scene affecting the underlying geometry. So then the idea would be then you would just kind of combine those, merge them back together to rebuild that beauty result here that we're seeing. And then you can kind of do the same to the volumetrics, and then you'll have specific control to adjust the intensity, color, what have you, of any of this. And then as you'll see too, if we go back to the Arnold Renderer tab and then go to the environment dropdown, we're not using that atmosphere input here in the render settings. When we did that before, if you recall in the first video, in the first method, we did not get any AOV result. It does not allow us to do that, since you need a physical volume object to exist within the scene when using Arnold and Maya. So we just used, again, that volume box cube, as it were, and then we just applied that AI atmosphere shader to that cube. And that allows us, since it's a physical object that exists in the scene, to get the AOV results that we're seeing here. And so that's how we can do it using this method. And so you can also include the volume AOV if you want as well as a combined result, just to test it. Maybe you're doing some early iteration to see if you even need these extra ones, so you can do that. You can also too, there's other volume AOVs. I should touch on that. So if you scroll down, you'll see there's a volume Z pass, and then albedo, opacity, and the like. And then there's also a volume direct and indirect pass. So I have those added as well. Now, I find that most of the time you'll get most of the result coming from the volume direct, and I'll often not even otherwise need the indirect, or it won't be perceivable that much anyways to your eye in the final result. So instead of splitting it apart into indirect and direct, I'll usually just use the volume pass. That's why I've been showing it up until this point. You can, maybe there's some cases where you want to separate those, so that is an option to you though, for those unique situations. I've never used volume Z or albedo or opacity, so you can test those if you want as well. But that's the second bonus method. So in the next part, the last part, before we come to a close here for this part 2 of this video and for this 2-part kind of series, I'm going to show you how we can composite these 2 methods that I've just gone over in Nuke, and how we can kind of reassemble this beauty pass using those light groups that I've created here from the original lights, as well as from those volume specific lights here in terms of their AOVs that I've created, and how we can kind of push and pull their intensity, their color, and all of that. I'll also show you how we can comp that previous bonus method that we just went over, where we had that kind of RGB channel separation approach used again, but just on that beauty pass, and then we would just separate it out using that primary volume AOV. So the benefit to that is that you just have a single AOV, and then you just separate the 3 groups in comp. Might be better for you. Kind of comes down to preference, the project you're working on, etc. at the end of the day. For this method, the upside is that it's much more streamlined. It's more simple in terms of what you're looking at and your look dev in terms of building things up and testing your lighting. You can keep those original values. You don't have to change them to RGB at any point. And then you just separate out them into their own light groups. So overall, it's pretty good. I might start using this more often, to be honest. There's also no render layer setup necessary at all for this either, which is very nice. The one downside is that it maybe creates a bit of a heavier final multi-layer EXR file that you would have to work with, and just more AOVs in general that you have to kind of keep track of, which shouldn't be a huge deal though, to be honest, at the end of the day. But anyways, I'll show you how we can composite these in the next section. I'm also going to go into Blender so that you can see how we can separate out the RGB channels in that. It's a bit of a specific, unique setup relative or compared to Nuke. In doing that, I'll often use Blender because you're not limited in your output resolution compared to the non-commercial version of Nuke, which is nice. So I've been using it a lot lately for final comp outputs for my projects that I've been working on. But it's good to know both. Nuke is often, for sure, more used in production scenarios. So it's still good to know that as well, of course. But anyways, I'll see you in the next part. Now let's go over how we can composite these 2 methods in Nuke. I'm using the non-commercial version. You can download that using the link in the description below. Now you'll see, first of all, I have both of the methods laid out here within my node graph. On the left, we have the RGB channel separation plus volume AOV approach, where we use those RGB channels to achieve that volume isolation, where we can then do fine-tuned adjustments. On the right, we have the light group AOV volume isolation method, where we would just use light group AOVs to kind of assign our corresponding volume sources to, and then we can use those to do our isolated adjustments using that approach. Now in the middle, you'll see I have an alt layout, an alternative way that you can go about setting up either of these volumetric setups within your comp if you are using more of a vertical comp tree. So I will go over that after I go over this setup on the left here. Now, first of all, relating to both of these approaches, you'll see I've used a very similar approach where I have the beauty pass on the left side of each of these, and then I've rebuilt the beauty pass using the light group AOVs that we set up and we've already gone over previously in this video. So you'll see we have the top light group result, and then the side far light group and the side near light group result. And that looks the same on both of these setups. Now that we've gone over a brief introduction of the comp setup for both of these and how everything is laid out, let's dig a little bit more into the RGB channel separation approach, and then we'll go over the rest of it after. So first of all, we'll start on the beauty side and go over how we kind of compiled this result using those light group AOVs. So first of all, if we double click on this shuffle node, which I created, you can just hit tab, type in shuffle, arrow down, hit enter. There you go. You can also hit the star beside it and that'll keep it up at the top whenever you hit tab. Now, if we double click on that, you'll see the properties for it over here. If we click on the shuffle tab, you'll see that I've specified the RGBA underscore top AOV to be active within this input layer. And then the RGB channels are connected to the RGBA output within the output layer. And so then that gives us that top light result as visible within the viewer. Now, if we go over to the node tab, you'll also see I have hide input turned on as well as postage stamp. With those turned off, you'll see that we now have lost the preview. And with it deselected, we also still see that input connection. I like to hide the input connection whenever I can, just to kind of keep things cleaner. Of course, there's times when you wouldn't want to hide it. For example, with this grade node, it just wouldn't make sense. You want to maintain that flow for efficiency's sake. But much of the time, I will hide the input connection whenever it makes sense, just to keep things cleaner. Now, if we turn on the postage stamp, you'll see a quick preview here. That's also helpful in certain cases. So that's what that allows us to do. We can see a quick preview of the result that we're getting from that. And so we have that B input on that shuffle going into that multi-layer EXR's beauty result, that kind of master read node. And then that allows us to pick from these AOVs. And so I have that RGBA underscore top AOV selected, and that's what we're seeing here. And so then the same thing was done for the side far lights AOV, the RGBA underscore side far AOV, and that's what that looks like right there. It's hard to see in the preview, but that is it right up there in the viewer. So if we go to the shuffle, you'll see we have it selected there as well. And then if we go down, let's double click on that. You'll see we have the RGBA underscore side near light group AOV right here. And so that's what that looks like right there as seen in the viewer. And so that approach is the same on the other side as well, where we use that light group AOV setup for the volumetrics. It's the same where we built up the beauty pass. It's the same general approach right there in terms of how we achieve that. And so let's go back over here quickly. Now, you'll also see that I have a grade node for each of these, doing subtle adjustments to each of them. In some cases subtle, in some cases maybe a little bit more noticeable. Now, you'll also see that there's this orange line connecting this grade node to this grade node. Now, that indicates that those are cloned nodes. And so to create a cloned node, you can right-click on a grade node, go edit, and then go clone. You can also do that kind of squiggly backslash with K, which I believe actually is Option K. That'll create that clone for you. And yeah, it is. Whoops, accidentally went over to the curve editor. That'll create the clone though, and then you just drag it into whatever pipe you want to. From that point, whenever you make an adjustment to one of those cloned versions, it will make that corresponding adjustment to both of those nodes, the one that was initially created as well as the cloned version of it. So you can make that change on, again, that cloned version of it or the original one, vice versa. It's essentially acting as an instance so that whenever you change the settings in one place or on one node, it will update on the other node as well. And so that's kind of helpful here in this case because the volumetric source here for the top light, of course, is coming from the same source as the result that we're seeing on the beauty layer. And so generally speaking, we would commonly want that to hook up one-to-one. That's much faster than having to copy and paste the node over to the other pipe whenever you make an adjustment. Now, depending on your setup, how you've output things, how you've decided to structure your comp in terms of your light separation or isolation, you might not need to create these cloned grades depending on how your comp layer is structured. But in this case, I felt it was suitable enough. Now, going back over to the beauty pass, you'll see that I also have these merge nodes here. This merge node at the top of this pipe is potentially not necessary, at least at the end of the day, it wasn't. We could have, for all intents and purposes, used a dot node here as well. I just wanted to create that preemptively in case I later on wanted to create a roto node to maybe isolate the area of effect or maybe cut off the light's effect on certain objects within the frame or do anything else there. I could have also added another element and merged it onto the B. It just kind of leaves the options open and creates a little more flexibility within the workflow. But again, not necessarily needed here at the end of the day. So we could have got away with a dot node there as well. Now that is also set to over for the operation. As you can see there, this one's also set to over. And that's just layering on that side far light. This one's layering on the side near one with that adjustment. And that's what that looks like. Now you also see there is a saturation node here that's making this result there completely white. That's just to have the same starting point that we see over here with the side near volumetric result. so that when we then add on that cloned set of grade nodes, they will have the same exact effect on each of these underlying results right there. If this was orange to start or warmer to start off with, it would have had a greater effect to this result as compared to this one. And there would have just been that evident disconnect. And so I wanted to desaturate that fully so that it would have the same starting point and then have the same ending result at the end of the day. And now down here at the bottom of the beauty set, this is just to display where I might decide to do a global adjustment to the beauty result that I wouldn't otherwise necessarily want to do on an individual light group result otherwise. And so this is where I would put my global tweaks commonly. So here you'll see I just changed the color of these spheres using these cryptomats. So I made sure that I created the cryptomat AOVs within Maya in the render settings under the AOVs tab. I moved them over into the active AOV list, all of the cryptomat options. So for material, object, and asset. And so then it just leaves my options open after I've rendered the image. And so if we just double click on it, you'll see I have this just set to object, and that then will use the object cryptomat that I've made sure to include in my AOV list. And just viewing it by default then will kind of have that visible in your viewer. And then you would just click on the pick or add box. You'll see a little eyedropper tool. Then if you hold Control, hit left click, sorry, not Control, Command. I think it's Option on Windows potentially. That will then add that object to your list. You could also manually add it in if you knew the name of it, and you could just kind of type it in here, I think. That could also work. And then to remove it, you just click on that and then hold Command again inversely, and then that will deselect it. Now, if you had multiple objects, say a bunch of light bulbs or something, you could also manually add an asterisk as a wildcard, and that would also then select all of those light bulbs within the image so that you don't have to manually click on each of them. And then for this one, that's just selecting the middle one, and then the grades are just pushing the color on it to be cooler. You can also warm it up or do whatever you want there. So then this one then is green, this one is blue. That's just for an example, of course, right? And then here I have a key mix. This is not actually doing anything. It could, if I wanted it to, do anything further than what it's currently doing, but otherwise, it's just kind of connected to this pipe over here, which is acting as a data pipe really to make sure that the information that's contained within this master multi-layer EXR is flowing down the main pipe to the right of it so that we have easy access to the data that is flowing down within it. So this cryptomat then is just plugged right into that pipe using this dot node. And then that gives us access to the metadata contained within this multi-layer EXR, such as that cryptomat AOV information, so that we can then go ahead and use these cryptomats as we need to. Now, you don't necessarily need this data pipe here in all cases, but it does help for efficiency, right? If you did not have this, you'd have to maybe drag that arrow all the way up there, which is not fun. You'd have this crossing of inputs, which makes things look really confusing and cluttered. Again, you could hide the input, of course, but just dragging it up all the way there even is just a little bit annoying and not the most efficient way to go about doing things. You also, this way, don't need to hide the input. You can see clearly what it is connected to, and since it's just right over to the left, you can easily enough just connect it right to that data pipe, and you're good to go. Now we have that going down into this merge node, which is set to over. That could potentially be just a dot node there, I think, as well. And that's just flowing into this merge node, which is set to plus, which is adding the final volumetric result on top of it. So now if we go to the top of this volume setup here within this methods approach, this also, by the way, is just a sticky note in case you wanted to know how I kind of set that up. That's just a sticky note. That's all that is. You could have also just put text inside the label of the backdrop. That could also work for you. But this is a shuffle node here that I created. I just changed the color to gray just to kind of make it stand out a bit more. But that is the volume AOV result that we are seeing right here, where I assigned each of the light sources to the RGB channels respectively. And then that shuffle within the volume backdrop is being plugged into that master multi-layer EXR file that has all of the data, including the AOV list. So then that is then selected from the AOV list here. We have the volume direct pass being selected there. I think this could also be the volume. I had that as the volume direct for a specific reason before to kind of cut out any indirect contribution. You'll see actually there was some splotchiness there with it as the volume. So the volume direct can sometimes provide a bit of a cleaner result for you. So I think that might have been why I used it. So we'll keep it as that for now. Now going down here, you'll see that same effect happening here, that slight adjustment of things being cooled off, and that's happening on the beauty side of things to that result, that light group AOV, as well as to the volumetric result from that same as kind of light source. And then that's being plugged into a merge node at the top, which is set to plus. In this case, we did end up using a roto. I just made a roto node and then use that to isolate the area of effect of the top volumetric light source. And so if we just double click on that, hit Q to turn our overlays on, you'll see that's just an ellipse there that I created by going over to this menu here. Yeah, and then I just selected ellipse, drag selected all the points and just moved it on up. And then I increased the feather all the way to 800. Going down here, let's hit Q again to turn off those overlays. You'll see that we have that grade node that's adjusting the underlying beauty result, just cooling things off, making it more saturated. That's also happening to the volumetric result. Here from the side far result right there. So if we just double click on that, you'll see that's being plugged into, again, that volume AOV, which has that RGB channel information. And so then we are then using this shuffle node here, where I also have these shuffles created in addition to this one. And these just kind of represent the RGB channel separation that I've set up here. So I just colored them accordingly. So this one, I just clicked on that box, changed it to red, and then I changed this one to green and blue just to represent what is being separated out from this result here. So that, as you can see, is the red result. That has the red channel plugging into the RGB inputs of the output layer. And then that is what we see there, completely isolated out from that guy. And then the side far one then is just completely isolated out from that. And that's what that looks like. And then we can see that change being applied. And then we have the side near one as well. We have hide inputs as well being turned on for all of these. That's plugged into that, and then that is being isolated out, and that's what that looks like. And then that has that change being applied to that because we have the saturation node desaturating this all the way. We have the same starting point as this, and then we have that being applied to that as well as that. Whenever the change is applied to one of these, then again, it is applied to both of them. So we can just take that, cool it off, do whatever we want. It changes on the beauty result as well as on the volumetric result. Now on the volumetric side, again, these are all set to plus, all these merges. I have another roto here. That's just bringing in that a little bit there on the edge. And then if we view that, this one here is just bringing that one in just a tiny bit, just to kind of naturally vignette things just a little bit. It's a subtle effect, but that's what that's doing. And this is what that final result looks like. So there you go. And that's what those global tweaks are doing again. Turn them on, turn them off. Again, that's just for an example, of course. And then this here, the alt layout, this is just to show you how you might set this kind of approach up if you were using more of a vertical structured comp layout. So if you are using a vertical comp layout, the information as it flows down the pipe would progressively add over top the data that you're adding into the pipe. And so your underlying beauty result here would likely be kind of above this right here, right? And this is kind of what that dot would otherwise represent. And so here we have that volume result being achieved just by this little node setup over here. So we have the master kind of multi-layer EXR result, what that looks like right there. And then we have that shuffle node with the volume AOV, the volume direct being plugged into the input layer there, or being assigned to that. And then we have these shuffle nodes down here, which are then being plugged into that RGB kind of volume direct AOV to get that RGB channel information. And then if we click on these, we have the red channel plugged into the RGB result there, as well as the alpha. I don't think the alpha is needed, but that still works nonetheless. And then the same thing over here for this result there, and then for that result there. They're named a little different. I think these originally came from a different project. Now you'll see the names on the shuffles are a little different, but that's okay. Over here, you'll see I just have some slight adjustments happening there too as demonstration purposes. And then we see those getting merged over top, and then that would come into there, and there we go. So that's how you would structure that, potentially in a more of a vertical comp setup. Over here, I just want to go back here very quickly before we move over to the second approach. This is just to kind of demonstrate how we would potentially strip out the volumetrics from our beauty result right here if we weren't using the light group AOVs to basically rebuild our beauty paths from the ground up. And so to do that, we have the master multi-layer EXR result here. As you can see, I have this dot just flowing into this shuffle node where we have, again, the volume AOV result. And then that's being plugged into the B input here of this merge. And the operation is set to minus. And then the master multi-layer beauty EXR file is being plugged into the A input. And then this is essentially just subtracting out the volumetrics, this result here, from this, and this is what we get. You'll see some subtle artifacting. It's not too noticeable, but it is there. It is visible to a degree. Now, from my experience, it's kind of a non-issue. Once you end up adding back on your volumetrics on top of it, it's nothing to be concerned about. And so I wouldn't fret too much about that. If you can find a result or a solution to remove that entirely from a similar type of setup, if you were not using light group AOVs to rebuild it, let me know how you might go about doing that in the comments for sure. And that would be awesome. But anyways, let's move over now to the second method's approach, the light group AOV volume isolation method. So everything over here on the left side, it's the exact same, and nothing is different. We just rebuilt our beauty paths in the same exact way. This is just to demonstrate here how we might use these cryptomats to make these isolated tweaks within one of the light group AOVs. I probably wouldn't want to do this up here at the light group AOV level if I'm changing the color or doing something more global to the final result, but that's kind of what you could do there. If I'm doing any kind of adjustment within a light group AOV, I would want it to be kind of more limited to maybe color adjustments, intensity tweaks, if it's subtle enough. Things like that. Or if maybe the result from the light group AOV is completely and only affecting an object by itself, then maybe you can do further tweaks to it to that degree. But otherwise, I would try to do more global adjustments at the bottom there, just as a heads up for that. Now on this side here, this is where things are more different in terms of the two setups. So I have, again, these shuffle nodes over here. We have one less shuffle node, which is kind of nice on the comp side of things. We don't have to have that volume AOV in its own shuffle and then have these plugged into it to kind of pull info or data from it. So we just have the shuffle nodes over here. They are connected to the main master multi-layer EXR file, which otherwise contains all the data. And again, we have that data pipe flowing down there in the same way. These guys are all plugged into that as well. They have hide input turned on through, again, that node tab, and postage stamp turned on to see that preview. And then otherwise we have the same kind of tweaks happening to those along the way, or at least very similar tweaks. And we also have these being rotated off to isolate the area of effect of these volumetrics a bit, to generally kind of vignette things to somewhat of a natural degree. The bottom underlying result from the beauty for the side far one looks like it could hook up a little better, but you get the gist of it. That's all I did though to set this method up. So if you double click on these, go to the shuffle node, you'll see I just selected the RGBA underscore top underscore vol light group AOV, which I created just for this method. So this method again does require more AOVs, specifically light group AOVs. There's just an additional one on top of the primary light group AOV that we use to recreate the beauty. And those additional ones have that, again, underscore vol suffix at the end of the name to signify that it is used for the volumetrics, right? And so then these are just pulling that information, those light group AOVs, into these shuffle nodes as opposed to the RGB channel information from the volume AOV. So in a sense, it's a little bit more simple. And this is the result that we get here with that layered together. So that's what that looks like. I should say that when I went over this the first time and batch rendered my renders out of Maya, the RGB channel separation approach took a little bit longer to render, and the quality seemed to be a little bit lesser than this method over here. This one was very clean out of the box. I had no issues with it. I don't know why exactly. This one was a little bit lower in quality in terms of it being noisy. The renders took 3 to 4 times longer. I think they were almost an hour per frame. For this method, it was about 10 to 15 minutes a frame, and they were very clean. I'm not sure if I adjusted one of the settings that I forgot I had adjusted maybe for this setup over here and forgot what it was. I don't know, but I tried poking around in it for a while and couldn't quite figure it out. So to resolve it, I just ended up using this file and then just kind of reverse engineering it to use this method's approach. Once again, saved it as a new file. And then I rendered this, this out again after that. And then the quality had kind of resolved itself and it rendered again around the same time as this one over here. So that seemed to fix it for me. But that said, that's it for this video for the part 2 of lighting volumetrics within Maya using Arnold and Nuke on the comp side of things. I hope you learned a thing or two. If you did, feel free to like and subscribe, and I will see you in the next one.